Today we are on Santa Rosa Island, part of the Channel Islands National Park. A national park that conserves and facilitates visitation to the California Channel Islands. My name is Jonathan Hoffman. I'm the Dibley Collection Manager of Earth Science at the Santa Barbara Museum of Natural History. We're actually in the Earth Sciences part of the Vertebrate Zoology Department and the Collections and Research Center. We're here today and for the next 2 weeks to finish the excavation and removal of the first known sea cow from the California Channel Islands.
My name is Brooke Roselle, and I am an undergraduate at the Pennsylvania State University. I'm a geosciences major. So right now I'm just removing some of the matrix here that's surrounding the exposed bone that's up front so that we can get as close as possible. Generally, just digging up a sea cow is really exciting. Slowly working down into it, it's just really rewarding to finally get as close as we can.
My name is Peter Close. I'm a PhD candidate in integrative biology at UC Berkeley. And right now I'm volunteering for the Santa Barbara Museum of Natural History on the sea cow dig. Right now I'm helping to widen the trench around the sea cow so we have better access to getting underneath it in preparation for flipping it and getting it ready to airlift. So I'm clearing through a lot of conglomerate around here, and yeah, it's coming out as one big block, and that's what I've been prepping.
So, what is a sea cow?
I can explain that better right here, back at the museum. Sea cows are also known as sirenians because they belong to the order Sirenia. Today, sea cows are represented by manatees, which are found along the Atlantic coast of North and South America and through the Caribbean, and dugongs, which are found in the coastal waters from the northern coast of Australia through Indonesia all the way to the eastern coast of Africa. Modern dugongs and manatees live entirely in the water, but their ancestors lived on land. They are terrestrial, not marine. This is true for other marine mammals, including this blue whale. This was about 50 million years ago during the Eocene epoch. Over millions of years, sirenians adapted to an aquatic lifestyle and spread around the world. Sirenians like to eat seagrass. Their snouts are angled downward, kind of like a vacuum cleaner attachment, so that they can eat seagrasses as they move along the shallow sea floor. Because sirenians stay underwater a long time, they keep a lot of air in their lungs. Sea cows also get gassy from eating all those plants, kind of like land cows do. This would make sirenians float, if not for some cool adaptations, including something called pachyosseosclerosis. Pachyosseosclerosis is a pretty long word, but it takes less time to say it than to explain it. It's a scientific term that refers to bones that are thick, hard, and dense. Pachyosseosclerosis is the condition of having thick, dense bones, like these sea cow ribs from our site on Santa Rosa Island. Sea cows are literally big boned. They actually have fairly low fat content relative to other marine mammals, but their heavy bones and their thick skin help weigh them down. They need to ride low in the water to stay at the level of their food without having to work too much. Because their bones are so big and dense, they fossilize well. This is how we know where sirenians have lived in the past. Seagrasses don't fossilize well. They don't really have the hard parts that can become fossils. This can make it difficult to figure out where they grew in the past. But because sea cows prefer seagrasses, we can suppose that where sea cows once lived, there had been seagrasses for them to eat. Because of their terrestrial ancestors, sirenians are surprisingly related to some herbivores on land. Some of the other descendants of those ancestors stayed on the land, so the sirenians have distant cousins up here. Among these distant cousins are modern elephants and prehistoric mammoths, like the pygmy mammoth that lived on the Channel Islands at the end of the Pleistocene epoch. Here at the museum, we have many mammoth bones from Santa Rosa Island, including the most complete skeleton of a pygmy mammoth found to date. So in our collections, we've reunited these long-lost cousins. And that's just a small part of the amazing heritage of the Channel Islands. It's so important that specimens like these end up in the hands of scientists who can learn from them and museums that can share them with you. That's why it's illegal to collect any fossils from national parks without a special permit like the one we have. If you find a fossil in a national park, you can help everyone. If you leave it where it is, take a picture, and tell a ranger. Please don't touch or move the fossil. Removing it from its context is bad for science because we lose all the information we could have learned from the things around it. This is why we're working so carefully to remove and preserve the clams and other invertebrates found around the sea cow. They can tell us more about the sea cow's habitat.
I am trying to very carefully extract this cast of clam, fossil clam, and in doing so, that happened to expose this bone material over here to the other side. So now I'm being even extra careful as I try to get this clam out of here. My name is Mark Clemens. I'm a professor at the University of Wyoming and the University of Wyoming Geological Museum. I'm using a dental pick. It helps me slow down my pace of going through the rock, and it's a little more delicate way of removing material so that you don't damage the specimen while you're digging through the sediment.
And what's that you have on the other end of the dental pick?
That is a cork. That is so that I do not stab myself with the other end of the dental pick.
Yourself or others?
I'm more worried about myself. But others, yes, yeah. I'm here because Dr. Hoffman, who is a former student of mine, invited me to come out and work the site. My research has focused on sea cows in the past, so when I learned that they had found this sea cow here on this island, the first fossil sea cow found in the Channel Islands, I was really excited to be involved and be a part of it, so it's an exciting prospect.
These fossils were discovered by scientists with the United States Geological Survey. They had been out here a couple years ago looking for faults as part of a mapping study and came across some bleached white ribs that they instantly realized were fossils, but they weren't sure what the fossils were of. So then a group of scientists came out again last year to take a look at those fossils, only to find that they had mostly weathered away. But while on site, we found a new set of ribs, and associated with that set of ribs, an actual skull. So since the Santa Barbara Museum of Natural History is the fossil repository for the Channel Islands National Park, we were tapped to take emergency actions to stabilize those fossils before the upcoming winter season. This was important because during the winter season is when this area gets the bulk of its precipitation, and we were concerned about those fossils being weathered, that is, beaten up by wind and rain. And if those were weathered away, we could lose them forever. So we came out here in fall of 2017, and the goal was to stabilize these fossils. That process involved first applying a special glue over the exposed fossils to help hold them together. This glue is a polymer that's been dissolved in acetone. And so after we had coated the exposed fossils with this glue, the acetone, which is like nail polish remover, evaporated, and allowing these polymers to link up and hold things together. This is important because it's also reversible. Once we're back in the lab, we can reverse this process by adding acetone again, dissolving those polymers. This is useful during the fossil preparation process. So after covering the exposed fossils with glue, we started brushing around and digging, looking for more fossils. The goal of this was to establish a perimeter around the bed of fossils. Once we had established this perimeter, we started trenching. And if we found more fossils, then we had to push that trench out a little bit farther. Eventually, we were able to trench down a couple feet around the bed of fossils and start a little bit of undercutting. And this would create a small ledge that we could then attach plaster bandages to put over the top and further protect the fossils. The first step of that process involved layering toilet paper over the specimen. We want to use some type of separation layer. Some paleontologists will use aluminum foil, or even, if you're real hard up, the wrappers from your fast food. The basic idea with a separation layer is to protect the fossils from any direct contact from plaster. Once we have these fossils back in the lab, you don't want plaster adhered to that fossil and potentially break it when you're trying to remove it. So first we put down that toilet paper layer, and then after that we started putting down these special plaster medical bandages. So these are strips of material that had been coated in gypsum. We then wet those and started draping those across the toilet paper layer. After a few layers of those gypsum bandages, we then took burlap and dunked that into plaster Paris to create an even thicker layer on the outermost layer. God, I keep saying layer.
Well, there's a lot of layers.
There's a lot of layers, like an onion. This was going to be necessary since we would have months before we could get back out here, and during that time we would see most of the precipitation for the year. The wind and rain, we were convinced, would do quite a number on these fossils, and we wanted to make sure they were protected. We did get periodic updates from National Park Service personnel who were still stationed on the island, but all the same, it was a little nerve-wracking to know that these fossils were sitting out here waiting for us to come back. When we came back here, the first thing we did was evaluate the plaster jackets to see if they held up and protected the fossils. And we were very pleased to see that the jackets had done their job. But also we saw that there had been quite a bit of erosion, and on the outermost thick layer of plaster, a lot of that plaster had been removed by wind.
Yeah, so what are you guys doing here?
So we are trying to widen the trench between two different jackets, it takes a lot of precision here. Because we've got so much material in the hillside that's been uncovered, we're trying to make this trench deeper, but we're limited on just how much we can widen it. Also, we've got a jacketed fossil here. We don't want to hit this with a hammer as we go along, and it's not uncommon, particularly later in the day, to start kind of missing your chisel a little bit and roughing up your fingers. Now we've got this added risk of hitting the jacket. Peter's been working on this primarily, and I'm just spelling him for the moment, and we'll swap out here in a minute. But I think he best described it as like plain operation. On top of all that, this is very hard material. It's well cemented conglomerate. And the lower you go, it seems the harder that it gets.
Well, the hardest thing about coming out here on this trip would just be the weather. The sun is just beating down on me. Since I'm going to school in Pennsylvania, we're used to it raining all the time when we're doing field work. So here it's completely different. It's just super hot, and just trying to combat that with a bunch of sunscreen.
Hi, I'm Chris Everett. I'm a master's student at UC Santa Barbara, and I'm here now volunteering with the Santa Barbara Museum of Natural History to help excavate this unique sea cow fossil.
What are you getting your master's in?
I'm in the paleobiology program in the Earth Science department. So this week I'm continuing my focus from the last time I was out here, which is on the skull portion of the fossil. And it's offset by a little fault from the main rib cage. So I got to work off a few feet away from the crowd to work on taking out this skull, which is going to be hopefully diagnostic of what type of sea cow this is. The last trip to Santa Rosa Island that we made, we were able to apply a plaster jacket to the skull to cover it up and keep it safe and prepare it for removal. And this week we're going to be able to dig under that a little bit more, flip it over, put more plaster on it, and then carry it out. And that's what we're preparing for. Even when it was exposed, most people would not have guessed that it was a skull. You're looking at only a portion of the top part of the skull is really visible, and we're hoping that some of the fragments will be able to piece together and get a better idea of the entire skull. So there are two options for what you might see when we flip the jacket. One would be some more bone exposed, and the other would be no more bone exposed. If there is bone, that means we misjudged how much we're dealing with, and there's going to be more work to stabilize that. If there's no bone, then we did our job right and less work for me. If anyone has seen the first Jurassic Park movie, you may be surprised that you don't see any scanners here to see through the rocks. And that's because technology doesn't really work that way. We have some ways of interpreting or scanning inside rocks to see fossils in a very expensive lab, but not out in the field. We have to just use our intuition and experience from finding fossils to know what we might be working with underneath the ground. The most rewarding part is, I think, finding more material where you're not expecting it. And I think, yeah, that's what keeps things exciting when you're just digging through solid rock. I'd say the most difficult part of this particular dig is because we're on a slope and the rock is really hard. It's hard to find a good place to sit and put your legs and get in a good position.
What do we know about what this area was like at the time that this dugong was alive?
This animal was living in a near-shore environment between 20 and 25 million years ago. Would have been located, even though we're on the Channel Islands today, this would have been located down near modern-day San Diego. And in the last 20 million years, these rocks have moved north, and it's the same process that helped create the transverse mountain ranges. As this block of land traveled up and slammed back into North America, the tectonics created an uplift of the rocks, creating the transverse mountain ranges, and in the last 5 million years, helping push up the rocks that would become the Channel Islands. And so these rocks had formed from sediments being deposited in a near-shore environment based on the pebbles we're pulling out of here, looking like maybe a opening mouth of a river or near it, feeding into the ocean. This animal would have been in this estuary-like environment before dying, being buried, and then all those rocks hitching a ride up north. We're hoping to get a lot more information about that setting through the invertebrate fossils that we're pulling out. So we're seeing a lot of gastropods or snail shells, and we're seeing a lot of bivalves or clam shells, scallops. We're finding all kinds of cool stuff that will ultimately, when we get back and start studying these different critters and identifying them, we'll be able to place them into context to learn more about what this environment was like based on previous research and knowing where these type of animals are found in other periods of history, including some of them with modern relatives today. I'm really hoping we find teeth, because on top of giving us information about the animal's evolutionary history, the teeth can give us additional information about the animal's environment. As a paleontologist who studies mammals, skulls with teeth are some of the best things you can find, because they give us information about the animal's evolutionary history, as well as all different types of ecological and environmental data that can be teased out.
So I've been trenching deeper around the edges of this jacket to prepare for this flipping. I'm gonna make sure that this part stays underneath. Well, what came out?
Yeah, I don't see any fossil material.
Yeah, it looks good.
They're looking good.
Yeah.
Woohoo! Sweet.
Are you happy?
Yeah. Oh yeah, this is what I was hoping.
Very nice.
Most of the bone is like in here, deep underneath here.
Yeah, very nice.
Is this the only time that paleontologists are happy not to see fossils?
Yeah, pretty much.
Very nice, yeah. I think it's important to learn more about the Channel Islands and their history, because when you look at the broader context of geologic history for this region, the Central Coast is really special. If you look at the California coastline, there's only one part that runs more or less east-west, and that relates to the tectonic history of the area. And so Channel Islands have large faults running through them that have resulted from those tectonics. And when we can use the dates that we'll get from these invertebrate fossils to figure out the ages of the layers, that'll help us understand when these different faults formed and start moving things around and just give a better idea of what has happened tectonically in a pretty unique area of the world.
So it tells us more about the mainland too.
Exactly. Yeah. The chunk of earth that the Channel Islands are a part of extends onto the mainland and includes Santa Barbara.
Everybody's favorite place.
And the Santa Barbara Museum of Natural History.